one good day in algebra. We'll be going over PO10, part 1. We went over essentially the first half last Thursday, where we talked about combining like terms. We talked about the distributive property, both of which are used to get these equations down to our comfort zone, which is our two-step equation. So you did have some homework. We're going to go over that now, correct it, and then get into some variables on both sides before the day is done. Your homework was actually on the part 2 page. There were 7 of them. Negative 20 equals negative 4x minus 6x. Two is the answer for that one. When you combine like terms, you get negative 20 equals negative 10x, negative 4 minus 6, and then divide both sides by negative 10, and we get 2 as our value for x. That one actually is simplified to be a one-step equation, even better. Okay. The next one, again, combining those like terms, positive 1 and positive 5. That gives us 6 equals negative 2n plus 6, which when you subtract 6 to move it over, you get 0 equals negative 2n, and of course, what number times negative 2 equals 0? 0 is your value for n, 0. Sometimes folks put it can't be done, right? But it can be done. Negative 2 times 0 does equal 0. The next one I didn't have you do, so we went down to 24 equals 5p plus 3p minus 8. So in this case, we can combine our variable terms. We have 5 p's. We get 3 more. Total, we have 8, right? Simplify. Why not just write 8? It's easier. Now it's add 8 to both sides. Divide by 8, and we get a value of 4 for p. Okay. Questions on those 3? Those are kind of the combining like terms, and the other 4 were, I believe, all distributive property stuff. Yeah. Okay. So moving on down to distributive property. Negative 8 equals 10 minus, and then in parentheses, x plus 4. What did you distribute into the parentheses? This is me trying to troll you. What did you distribute into the parentheses? Sydney? Just the negative sign. And in fact, a negative 1. Okay? Not the 10, because you're not multiplying the parentheses by 10. You're multiplying them by negative 1. So when you do that, you get negative 8 equals 10 minus x, and then minus 4. Essentially, all it does is it changes the signs of whatever is in your parentheses. Now we can combine some like terms. Negative 8 equals 6 minus x, just 10 minus 4 gives us 6. Subtract 6 from both sides, get x by itself, but it's not by itself. What's our last step that we need to do here to get x by itself? William? Miranda? Not by 1, because divided by 1 isn't going to change anything, right? Negative x divided by 1 is still negative x. So we want to divide by Violet? By negative 1. Is that darn negative 1 again? Okay? That's our coefficient. Whatever x is, we're multiplying it by negative 1. So to undo that, we're going to divide by negative 1, and we get positive 14 equals x. Positive 14 equals x. Now, if you got this question incorrect, you should have caught that when you plugged it back in to check it, right? If you left it as negative 14 and you went up here and you said negative 8 equals 10 minus negative 14 plus 4, well, negative 14 plus 4 is negative 10, and so then you'd have negative 8. What did I just do? I broke it. Okay, you'd have negative 8 equals 10 minus negative 10, which that equals 20. And negative 8 doesn't equal 20, right? So if you did get that one wrong, you should have caught it when you checked it and then gone back And then if you couldn't figure it out, say, I don't know what to do. Then you go to the question form and you say, hey, Mr. Schultz, can you help with question number 6 or whatever it is? Okay. But positive 14 is the answer. Last row, distribute in that negative 4. So we have 20 equals negative 64x minus 12. 20 equals negative 64x minus 12, because don't forget that sign belongs to the 4, so it's a negative 4. Add 12 to both sides. That gives us 32 equals negative 64x. Our brain wants to come up with negative 2, but what is the answer? Peter? Negative 1/2. You would divide both sides by negative 64, and 32 divided by negative 64 is negative 1/2 or negative 0.5. If you put the decimal form, that's fine too, but that would be the answer, negative 1/2. And again, if you did put negative 2, then you should have caught that while checking it. Next one, distribute in the 6. So we have 12 equals 6p minus 48. Add 48 to both sides, initiate opposite operations, divide both sides by 6, and we get a value of 10 for p. And the last one, distribute in that negative 4. That gives us negative 28, positive 20x, because it is a negative 4 times negative 5. Okay, so it's positive 20x. That equals 12. Add 28 to both sides. 20x equals 40. Divide both sides by 20, and we get 2. Okay, we get 2. As you look at my work and compare it to your own work, if the mistakes that you're making are with signs, then I really encourage you, take your time, write out each and every step, think about it, and then check your answer. The check your answer goes for everybody. But if your mistakes are with signs, those are just details that you're missing. So slow it down. Okay? Slow it down. If your mistakes are more with the process, like maybe you're subtracting 48 here rather than adding 48 to get p by itself, or you're subtracting 12 rather than adding 12, you're not doing the opposite operations correctly, then that goes back to, go back to PO9 and take a look at your work there and kind of practice that. So the more you're able to identify where your mistakes are happening, the better you can help yourself, and I can ultimately help you there. Does that make sense? Okay. And you want me to go over in further detail? No? We're good? Okay. Very well. The second part of PO10 deals with variables on both sides. Okay. What is your experience with variables on both sides? For example, if we've got 16x minus 5 equals 12x plus 23. Have you worked with variables on both sides before? A little bit. Our goal is still to create a two-step equation, right? That's always the goal. Because two-step equation, that's our comfort zone. That's where we're happy. Okay, we know what to do there. So the goal is to move variables to one side to get a two-step equation. Move the variables to one side to get a two-step equation. Okay. And as it says in the count of mistake here, it's the same moving to one side as it is when you move a constant from one side to the other. Whenever you are moving something, moving an entire term from one side of the equation to the other, we're using opposite operations here. So 16x minus 5 equals 12x plus 23. For some reason, I think I put an extra space in between the equal sign. It's going to bug me if I don't fix it. Get rid of that blue line there. Let's see. Word, are you happy? Word. Word is happy. So what can we do here? Who wants to give us our first step in moving those x's to one side of the equation? Yeah, Will. We certainly could. Okay, and how would we move those positive 12 x's over to the left side? Go ahead, Will. Okay, so if we have 16x minus 5 equals 12x plus 23, and we want to move those x's over to the left side, we're going to subtract 12x. Because if you have 12 x's on the right side, now you have 12 x's, you take away 12 x's, how many x's are left on the right side? 0. Right? You've canceled them out. Then on the left side, 16 minus 12 gives us 4x minus 5 equals 23. Okay. The reason why we're not dividing by 12 here, because in PO9, right, whenever we dealt with the variable term, we always divided. Okay. The reason why we don't divide by 12 here is because we're moving the x over to the other side with it. You know, in PO9, like here, we're adding 5 now. We've got a two-step equation. Add 5 to both sides. We get 4x equals 28. Here we're dividing by 4 because the x doesn't move, right? In that two-step equation process, 4x dividing both sides by 4, we divide by 4 because we want x to stay right where it's at. We want to get x by itself. We want to separate the 4 from the x. But when we're moving these variables over, we want to keep those 12 x's together. Okay? That's why we subtract there and not divide. So Will said his suggestion was to move the 12 x's over to the left. Could we instead move the 16 x's over to the right? Indeed we can. Okay? 16x minus 5 equals 12x plus 23. Another option would be to subtract 16x from both sides, cancel them out on the left side, because 16x's minus 16 is 0. We're left with negative 5. And on the right side now, we've got negative 4x plus 23. So we still end up with that 4x difference, right? The difference between 12 and 16 is 4. But if we move our 12 x's over to the left side, it's a positive 4 because there are 4 more x's on the left than there were on the right. If we move our x's over to the right side, it's a negative 4 because there were 4 less x's on the right side than the left side, right? 12 is 4 less than 16, and that's why they're negative when we move them over there. But we have our two-step, subtract 23 from both sides. We get negative 28 equals negative 4x. Now we're dividing by negative 4 to get x by itself, and lo and behold, our answer is still positive 7, which is good. Whew, if we had gotten something else, I've been concerned. Okay, but it is still positive 7. Any questions on that? Initial questions? First time seeing it? Some of you, it's certainly understandable if there's something that isn't quite sticking. No? Okay. Sometimes I like to equate this to like sports. You know, if you are play basketball and the score is 16-12, right? This is like our 16 x's on one side, 12 x's on the other side. Isn't that really just the same as 4-0? I mean, you know, your points total doesn't matter. It's just that you score more points than the other team to win. So there's a correlation here between having 4 more x's on the left side and the fact that we had 4x when we moved those x's over, right? Or if you have the 12 points being down by 4, right? 4 less points, there's a connection with that negative 4 over on the right side. So some people just like to look at this and say, let's look at the second one here. Which side has more x's on it? -8 versus -5. This one might be more relatable to like a golf score, those that golf. Okay? -8 to -5. Which side has more x's? Caleb. Negative, oh, they are n's, sorry. -5. Yes, okay, the right side has more n's. -5 is greater than -8. How much greater is -5 than -8? How many more n's are on the right side? Do you know? 3. So some people can just look at this and think, okay, I got -8 on the left, -5 on the right. That's 3 more on the right side. So I'm just going to write this to be 9 equals 3 minus 18. And that's okay. Because if we do opposite operations here, if we want to move our n's to the right side, how do we undo having -8 n's? Joey?
You cross it over.
How?
So you would
What's the opposite of a -8? Joey? A +8, right? So we're going to add 8 n's to both sides because -8 plus 8 equals 0. And what do we get when we add 8 to -5? +3. Okay? So, there is an opportunity here to kind of, quote unquote, skip a step and not showing that this first addition or subtraction by looking at the equation saying which side has more and then how many more. The right side here had 3 more n's, and so we get 9 equals +3n minus 18. Of course, the other way is to actually do the math, the opposite operations there, add 8n to both sides. -5n plus 8n gives us that +3n. Two-step equation, I like it. We're going to add 18 to both sides. Again, opposite operations. Cancel that constant out. 27 equals 3n. Divide both sides by 3 to get n by itself, and we get a value of 9. Okay? Questions, comments, concerns, complaints, comments, congratulations, or criticisms? Okay. Those of you that have been kind of working ahead a little bit probably got to the third one and say, whoa. What's going on here? Okay? What's different about the third one than the first two? Violet? Yeah, we got the same number of n's on both sides. Okay? The same number of n's on both sides. Which means that, when we subtract 9y from one side to cancel it out, what's going to happen to the 9y's on the other side? They'll also cancel out. If we envision this as like a balanced scale, you've got 9y's on both sides. There's no more or less. You can take away those 9y's and your scale is still going to be balanced, right? Because you took away the same number on both sides. So we're left with -12 equals 18. Because we have the same number of variables, they cancel out completely on both sides, and we're left with -12 equals 18. Does -12 equal 18? Will -12 ever equal 18? No. So what that means is that there is no solution. Your teachers that told you growing up, there's always an answer. Well, there's not always an answer, okay? There is no value for y that when you plug it into this equation will make it true. Because in one case, you've got 9y's, and then you take away 12. And on the other side, you have those same 9y's, but you're adding 18. That's never going to be equal, okay? So if you've got variables on both sides and they cancel out, and you're left with an equation that is not true, -12 is not equal to 18, there is no solution, which means that, and that's the symbol by the way, the no solution symbol is a 0 with a line through it. Not 0, Okay, but a 0 with a line through it. No solution. The fourth one seems to be a little bit tricky as well. What do we notice about the fourth one here? Joey?
They're both balanced out like the previous question.
What do you mean they're both balanced out? What's balanced out?
The variables.
And
And the constants.
in this case, if we combine like terms, on the left side we have 8n plus 7. And on the right side we have the exact same thing, 8n plus 7. Because we have the same number of n's on both sides, we can go ahead and cancel those out, right? 8n minus 8n, you move it over, you're going to end up with 0. That leaves us with 7 equals 7. Is that true or false? True. Which means that any value you plug in for n is going to make this equation true. Hey, Peter, give me a number 1 through 10.
10.
Sure. If n is 10, 8 times 10 is 80 plus 7 is 87. That's equal to 8 times 10, which is 80, plus 7, which is 87. Okay, Gino, give me number 1 through 10. Pick a number. 7. If n is 7, 56 plus 7 is 63. The right side, 8 times 7, 56 plus 7, still 63. Okay? If you pick negative 5, 8 times negative 5 is negative 40 plus 7, negative 33. On the right side, negative 40 plus 7 is negative 33. Every single number is going to work, which means that instead of of no solution, oh, I can't even spell solution, I'm so excited. All solutions, okay? All numbers are going to make this equation work because it's exactly the same. And the symbol for that is a double stemmed R, so make kind of like an 11. And then start from the first vertical line and make an R connecting it to the second one there. That's the all real number symbol. It means that anything that you plug in there is going to work. Don't you feel so much smarter today than when you walked in here? Yeah. All right. So let's kind of skip down. Any questions on this, by the way, before we go on? Okay. So let's kind of skip down to where do we want to go? Let's go to this page here. Okay. Where you had your homework due for today, and let's look at this second row, first one here. 5p minus 14 equals 8p plus 4. Go ahead and make your two-step equation. You don't have to solve it the entire way, but just make your two-step equation. Get all of those variables on the same side. You can think about it with opposite operations. Just move the variable term from one side to the other, or think about it as a basketball score, which side has more and how many more. So your two options for what you could have, either negative 3p minus 14 equals positive 4 if you moved all of the p's over to the left side, or if you went to the right side, you should have negative 14 equals positive 3p plus 4. One of those two things, right? Because either you subtracted 8p from both sides to cancel them out from the right side, in which case you have negative 3p over on the left side, 5 minus 8, or you subtracted 5p from both sides to cancel them out from the left side. Don't forget that sign belongs to the 14, right? Negative 14. Then 8 minus 5 gives you positive 3p over on the right side. Everyone good? Okay? Then you would continue solving it whichever way. Add 14 to both sides here. Negative 3p equals 18. Divide by negative 3. P equals negative 6. Or subtract 4 from both sides here. Negative 18 equals 3p. Divide by 3. You get the same result, negative 6. Okay? Where things get really fun, and you're eating in the lunchroom today, so we got to wrap up here soon, but where things get really fun are like on the second page of this. Oh, yeah. Oh, yeah. Let's look at this first one here. Negative 18 minus 6n equals 6 times 1 plus 3n. You've got the distributive property. You've got variables on both sides. Time for fun. What do we do first? Do we distribute or move variable terms around? Peter? Distribute. Get rid of those parentheses. So we're going to put the 6 in. That gives us negative 18 minus 6n. 6 times 1 is 6. 6 times 3n is positive 18n. Right? The left side doesn't change because we didn't do anything there. There wasn't any parentheses, wasn't any like terms. We just leave it as is. The right side, we distribute in the 6. Which side of the equation has more n's? Which side has more? Thomas? The right? 18 is more than negative 6. How many more does the right side have? How much greater is 18 than negative 6? Not 12 greater. Think where negative 6 is on the number line. Think where 18 is on the number line. Actually, for you, it's backwards. Negative 6, 18. How far away are those numbers? 24 away. 24 away. So you could just go ahead and say negative 18 equals 6 plus 24n, although sounds like we are still in that step, which is totally fine. Don't get me wrong here. But adding 6n to both sides to move that over to the right. The reason why we're adding here is because negative 6 plus 6 is how we get 0. And then 18 plus 6 gives us 24n on the right side there. Okay. You could also subtract 18n from both sides and get negative 24n over on the left. In either case, two-step equation, we're happy, comfort zone, subtract 6, negative 24 equals 24n. Divide both sides by positive 24 to get n by itself. And we get negative 1. Okay. Completely understandable if on like a scale of 1 to 5, 1 being you've never seen this before, and a 5 being you could be up here teaching it. If you're somewhere around that 2, 3 range, because it is the first time that you're seeing this, some of you, and so there's expected that there's going to be some things that you just have to practice through, which is why we have homework. So your homework for Monday, no. Tomorrow, we have class tomorrow. Your homework for tomorrow, I would like you to do, let's look back to the front side a little bit. Let's get, let's do, yeah, these, how high does this go, right? Oh, marker down, hold on. There we go. Okay. I want you to do this one, the third one in the first row, variables on both sides there. The first one in the second row, variables on both sides. The next one in the second row, variables on both sides. We did this one together already, so we don't need to go over that one. This one in the third row. That's it?
Yep.
All right. No, you'll get the second part of page 2 or tomorrow. But yeah, just these 4, just a few to practice on. Just a few to practice on for tomorrow. That is how you math.